We are starting Module 3. So Module 3 is on expressions and equations. So that's what that 3 here means. And Lesson 1 in this module is on generating equivalent expressions. Now remember, expressions, when we're talking about expressions, no equal sign. And equivalent means equal. So basically, we're taking these things, these expressions, they don't have an equal sign, and setting them equal to each other. That'll make more sense in a little bit. But I want to remind you of some terms that you've learned in the past. And one of the terms that I want you to remember is term. So actually what I'm going to do is, if I can, click in here. All right, a term. And guys, I want to be honest, these are my definitions of how I think of these words. I believe I attached in your notes. If we scroll all the way here, these are the technical definitions. So you can see a term right here. Each summoned means add of an expression in expanded form is called a term. All right, well, I'm not going to say that. So you guys have all these exact definitions. Here's Mrs. Messing's definitions. Term, okay, the parts of an expression that are being added together. The parts of an expression that are being added together. Okay, and that's really important there because sometimes we'll have subtraction signs. Not a big deal. We know how to change it to adding, but it's going to be really important that we always change things to adding. Then we have like terms. Well, if we know terms are the parts of an expression being added together, like terms are going to be those terms that have identical variable parts. Now, we've talked in class about don't get all caught up in this whole variable thing. Oh, we got letters in math. No. They're numbers. They're numbers we don't know. So we have to have a symbol that represents that number we don't know. That's a variable. Okay? So like terms are going to have identical variable parts. Think identical means it can't be an X and a Y and say they're both letters. No. Like terms are going to be the exact same variable parts. X and an X. A Y squared with a Y squared. And again, as we do examples, that'll make sense. Coefficient is the other one you're going to hear us refer to. And here's how I usually say it. The coefficient is the number attached to the variable. But I really should say multiplying the variable. Because some people take exponents and say, hey, that number's attached to it. No, it's the number out front. It's the number that means we're multiplying by. Okay? So these three things that should be review, but it's going to be ones that you're just going to need to know what they mean. Okay? So if we look at example 1, it says in any order with any grouping property or any grouping property with addition. It wants us to rewrite this and this by combining like terms. Combining like terms. Whew. Struggling with draw the line. And now I'm going to scribble. Okay, let's move on. All right, so like terms. Like terms of identical variable parts. Okay. And when we combine them, we add them together. So I want to show you what these actually mean. Okay. And we're not going to do them like this every single time. So if I need to have 5x plus 3x, what does that actually mean? Well, this 5 times x here, that's repeated, multiplication is repeated addition. So it means I'm taking 1, 2, 3, 4, 5. 5 x's, right? And I'm adding it to 3 x's. So if we have 5 x's, we're adding it to 3 x's. That's 1, 2, 3, 4, 5, 6, 7, 8 x's. Okay, so again, this 5x, that's multiplication. Multiplication is repeated addition. If we took 5x minus 3, I'm sorry, minus 3x, that means I have 5 x's being added together because that's what multiplication is. And then I'm subtracting 3 of them off. Okay, so maybe I'll start here. here's my 5x's. And if I take 3 of them off, what am I left with? 1, 2, 2x's. Now we shouldn't have to write it out like that all the time, because hopefully we can see that if I have 5x's plus 3x's, I can just add the 5 and 3 to get 8. If I have 5x minus 3x, I can just go 5 minus 3 to get 2. Okay? Now taking it to the next step. Now we're just not expanding them. Okay? We're not going to expand them anymore. We're going to perform some operations. And again, operations are adding, subtracting, multiplying, dividing. Find the sum. Sum means to add. It's the solution to an addition problem. So if I know I'm adding, come down here to the and put a plus. So if I want to find the sum of 2x plus 1 and 5x, that means I'm going 2x plus 1 plus 5x. All right, so now here's where it's important that we recognize what like terms are. Because if I'm adding these together, I can't add 2x and 1. All right, let me show you. If you think that 2x plus 1 equals 3x, right? 2 plus 1 is 3. Well, they should be equal to each other, right? So what if I said x is 1? Well, 2 times 1 plus 1. Well, 2 times 1 is 2, plus 1 is 3. And guess what? 3 times 1, that equals 3. Okay, so it works. But what if x is 2? 2 times 2 is 4, plus 1. Well, that's 5. And 3 times 2 is 6. Doesn't equal. It works when it's a 1, but it's not going to work for the rest of them. That is why this doesn't equal that. Okay? So we do like terms. Remember, those are identical variable parts. And so if I look here, I have 2x's and 5x's. Those are identical variable parts. They're both x's. And remember, with adding, we can change the order. So I can rewrite this as 2x plus 5x plus 1. And 2x and 5x is 7x plus 1. And when we get there, stop. Okay, and that's what's hard about this. It might be the hardest part, is because we want to write an answer. But remember, this whole lesson is on expressions. In expressions, we only get an answer if we know the value of the variable. Simplifying. Okay, now this one also says find the sum of negative 3a plus 2 and 5a minus 3. So I'm adding together negative 3a plus 2 and, so plus 5a minus 3. Now, before we can simplify this, we got to remember what terms are. And they're the parts of the expression being added together. Got a little problem here, right? It's not a big problem, though. I am a subtraction sign. But instead of subtracting 3, I can think that subtracting is the same thing as adding the opposite, or keep, change, change. Don't forget to do that part, because otherwise you're going to combine like 2 and 3 together, and it's not 3, it's negative 3. Okay, so now pull out your like terms. You can change the order physically and write it down, or you can just understand that once it's adding, we can add in any order. If I have negative 3a's and 5a's, put them together. Just go negative 3 plus 5, and when you do that, you get 2. That means I have 2a's. I'm going to give myself a little more room here. And then I'm going to put a double line under other like terms. Now, 2 and negative 3, they're like terms as well, because remember, like terms have identical variable parts, and they're identical in the fact that they don't have a variable. So then you're just going to go 2 plus a negative 3, and you're going to get negative 1. Okay? Or, and you don't have to write both, you could write this as 2a minus 1. Okay? Crazy thing again, you guys, this is your solution. Okay? When we have to simplify, and we don't know the value of those variables yet, our answer includes the variable in it.